Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at ASA access control lists. We'll be discussing the types of ASA access control list filtering, syntax for configuring and applying an ASA access control list. We'll look at some ASA access control list examples. We'll look at access control lists and object groups. And finally, we'll take a look at access control lists using object groups. This episode is part of my series on network security for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. There are similarities between an ASA access control list and an iOS access control list. One of the main things is access control lists are made up of one or more access control entries. So inside your access control list, each line, each one of those access control entries. And so if you have an ACL, they have to have at least one access control entry. Now, access control entries are applied to a protocol, a source or destination IP address, a network, or the source and destination ports. That's how ACEs are configured. The next one, that similarity here, is ACLs are processed sequentially top down. You start at the first access control entry in your access control list. So start at your first ACE. Doesn't match that criteria. If it matches it, let's go ahead and do what it says and process that. If it doesn't match it, it goes to the next one. It goes to the next one. It goes to the next one. The next part here is a criteria match will cause the ACL to be exited. So when it matches that access control entry, if it matches it, that ACL will be exited. At the end, there's the implicit deny at the bottom of it. So if it doesn't match any of the access control entries, when it gets to the end, it's just going to deny everything. Remarks can be added per access control entry or access control list. So you can add in per access control entry or access control list. Another similarity is only one access list can be applied per interface, per protocol, per direction. So only one access control list per interface, per protocol, per direction. And finally, ACLs can be enabled or disabled based on time ranges. You can have access control lists based on time. An example here would be outside of normal work hours, let's shut our network down to a lot of access. Let's have a special access control list that shuts down our network, shuts down internet access, any of that type of stuff outside of normal business hours. Then when normal business hours start, let's go back to our normal operating network parameters. There are a handful of differences between an ASA access control list and an iOS access control list. One of the big ones here is the ASA uses a network mask. So it uses our normal network mask, starting with all ones followed by zeros. So 255, 255, 255.0, where if you remember on the iOS, on a router, it doesn't use a subnet mask. It uses a wildcard mask, which is zeros followed by ones. And so the equivalent of the subnet mask up here of 255, 255, 255.0, on a router, you'd specify the wildcard mask of 000.255. The next difference is ACLs are always named. So you can't have any numbered ACLs. They're always named on our ASA devices. And then the last one. By default, interface security levels apply access control without an ACL configured. On our ASA firewalls, an interface has security levels applied to it without creating any access control entries. On a router, you have to control access using an access control list. Otherwise, there is no access control at that point in time. On a firewall, on an ASA firewall, by default, there is some access control configured. ACLs on a security appliance can be used not only to filter packets that are passing through the appliance, but also to filter packets destined for the appliance. Now, there's two types of methods to do this one. First is the through traffic filtering. Traffic passing through the ASA from one interface to another interface. The configuration is completed in 2 steps. First, you configure the ACL, then you apply the ACL to the interface. The second one here is to-the-box traffic filtering. This is for management access, so you create a management access rule that applies to traffic that terminates on your ASA firewall. ASA devices differ from their router counterparts because of interface security levels. By default, security levels apply access control without an access control list configured. Once again, ASA devices differ from their router counterparts because of interface security levels. By default, security levels apply access control without an access control list configured on ASA firewalls. When you look at security levels, the one rule here is a higher security level can access a lower security level without having any access control list configured. So the higher your security level, the more trustworthy a interface is, or an interface connected to a LAN, the more trustworthy it can connect to lower trustworthy interfaces. In a typical example, you have your ASA. Here we have our ASA in the center here, and we have 3 connections. We have our inside, our outside, and our DMZ. Security levels, once again, go from 0 to 100. And our inside connection should be your most trusted connection. So we give that a security level of 100, the highest possible. The outside here, that's the internet. That's the wild, wild west. Yes, there may be legitimate people trying to get into your company, salespeople, your trusted partners, that type of stuff. But there's probably threat actors trying to get into your network also. Because we don't know who exactly is out there, what we're going to do is we're going to assign that a security level of 0, the least trusted. In an organization, there may be devices that need to be accessed by both the outside networks and inside networks. That's where we're going to have our DMZ. And we set the DMZ security level to somewhere between 0 and 100. Most of the time, by default, we take right in the middle. We'll set it at 50. Now we have our security level set. Inside's 100, outside 0, DMZ is 50. What happens here, without having any access control list configured, the inside, because it's the highest security level, they can trust any other security levels that are lower. So the inside people, they can go to the DMZ. They can connect into the DMZ because that's a security level of 50. The inside's 100, the 100's higher, so they can connect into the DMZ. The inside can also go to the outside. The inside can go to the outside. The inside's 100, outside is 0, inside's higher, so the inside can access the outside. There is also one more way we can access data, and that would be from the DMZ to the outside, going from security level 50 to security level 100. So 3 different ways by default data can get accessed through our ASA firewall. This also means that a lower level cannot access a higher level by default. You would need to have special access control lists configured. Right now, without any access control list, we're looking at the outside network with a security level of 0. They basically can't access anything at this point in time. The DMZ has got a security level of 50. That's higher than the 100. So they cannot access the outside cannot access the DMZ. Outside has that 0 security level. Inside has 100 security level. Outside cannot access the inside. We also, DMZ cannot access inside. We're going from a security level 50 to security level 100. You can't go higher. So we cannot make that connection there. I'm sure some of you are thinking, well, that's why we set up the DMZ, is to let the outside get access to that. Once again, I said by default, without any access control list configured, these devices can't access a higher security level. In order to allow outside to access the DMZ, the web server in that DMZ zone, you have to set up a special access control list to allow that traffic. When we're talking about allowing and disallowing traffic based on security levels, there's one more command we should be familiar with, and that command's got 2 different options and makes it do 2 different things. The command here is same security traffic permit. So same security, traffic permit, same dash security dash traffic space permit. And then you can either do interface, so INTER interface, or intra interface, INTRA interface. So inter interface, INTER, this is to enable traffic between interfaces with the same security level. The intra interface, INTRA, this command is to allow traffic to enter and exit the same interface. So inter goes between two different interfaces. Intra allows the same traffic to exit and enter that same interface. I hope you're liking this episode on ASA Access Control List. If you have the time, please leave a comment and let me know what you think about ASA Access Control List. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. The ASA supports 5 types of access control lists. First one is our extended access control list. This is the most common type of ACL. The second one here that the ASA supports is a standard access list. Unlike the iOS, where a standard ACL identifies the source network, the ASA standard ACLs are used to identify the destination IP addresses. Standard access lists cannot be applied to interfaces to control traffic. The third type of ASA ACL is the Ether type access list. Now, this can be configured only if the security appliance is running in transparent mode. The fifth type here is web type access list, and this is used to filter for clientless SSL VPN traffic. These access control lists can deny access based on URLs or destination addresses. And the last access control list type is IPv6 access list. This is used to determine which IPv6 traffic to block and which traffic to forward to router interfaces. We can also use the help access list command here to display the syntax for all the ACLs supported on the ASA platform. There are several types of uses for extended access control lists. The first one here would be to control network access for IP traffic. What happens here is the ASA does not allow any traffic from a lower security interface to a higher security interface unless it is explicitly permitted by an extended access list. Another way that it's used is to identify traffic for AAA rules. AAA rules use access lists to identify traffic. The third one is identify addresses for NAT. NAT policy lets you identify local traffic for address translation by specifying the source and destination addresses in an extended access list. The fourth one here is to establish VPN access. And we can use an extended access list inside of our VPN commands. And the last one is to identify traffic for Modular Policy Framework, or MPF. What happens here is the access list can be used to identify traffic in a class map, which is used for features that is supported by our Modular Policy Framework. Features that support Modular Policy Framework include TCP, general connection settings, and inspection. A couple uses for standard access control lists on our ASAs would be first to identify OSPF destination network and route maps. Standard access lists include only destination addresses. It can be used to control the redistribution of OSPF routes. And the second one here for standard access lists would be VPN filters. Filter traffic for LAN to LAN or Cisco VPN client and the Cisco VPN AnyConnect secure mobile client traffic. A use for an ASA IPv6 access control list would be to control network access for IPv6 networks. This can be used to add or apply access lists to control traffic in your IPv6 networks. iOS and ASA ACLs have similar elements, but some options vary with the ASA. There are many options that can be used with access control lists. However, for most needs, I'm going to cover the more useful and a condensed version. We start off by creating our access control list. We start off with the word access-list. Then we give it the ID, which is the name of it. We're basically always use anytime we're doing filtering or creating access control lists on our ASA that's extended. Next is our action. This is where we either have deny or permit in there. You have to choose one of those two. Then we specify the protocol. The protocol is once again our IP, TCP, UDP. Then we get into looking at the source addresses. So you either put in your source address with the mask. You can use a keyword of any. You can use the keyword of host and you just put in the IP address. Or you can specify the interface with the interface name. Any one of those come next. Then we go ahead and we specify the operator. And then once again, our operators, it can be LT for less than, GT for greater than, EQ for equal, NEQ for not equal, or we can do a range for an inclusive range. Port could be a port number or TCP UDP port name. It could also be a service object or group. And so lots of variables in there, flexibility for you. Then we go ahead and we specify our destination traffic to filter. Once again, you can put in the destination address in the mask. You can use the keyword of any or host or interface with the interface name. And of course, then we put in our operator here and port. Next, we'll talk about the command syntax and parameter description for applying the ACL to an interface. What we do here is we use the access group command. So what we're doing is we already have an established access control list and we're going to apply it to an interface. So we use access-group, then we put in the ID. This is the actual name of the actual access control list to be applied to that interface. Then we say either in or out. You have to choose one of these two. And this is whether the access control list is going to filter inbound packets or outbound packets. Then we have the keyword of interface and then the interface name here. And this interface name is something like inside, outside, DMZ. If you set up something for maybe different departments, maybe you have management, accounting, R&D, whatever fits your network, however you set it up, that's the name of one of those interfaces. And then we have an option here. We can either specify per user override or control plane. Per user override here is an option that allows downloadable access control lists to override the entries on the interface access control list. The control plane here, this option, is a keyword to specify whether the applied access control list analyze traffic destined to the ASA for management purposes. To verify our ACLs, we can use a show command. So it's show access -list command. That'll give us one, or we can also do a show running access -list command. So show access -list or show run access -list. And those two commands will give you information about your configured access control list. Now, to erase a configured access control list, use a command here. The command here is clear space config access lists, and then the list ID number, the name of your list. So to remove a configured access control list, it's clear config access -list and then the name of your access list, and it will remove your access list for you. There's a couple of ASA access control lists I'd like to talk to you about. The first example here is this ACL allows all hosts on the inside network to go through the ASA, and then by default all their traffic is denied unless explicitly permitted. So what we did here is we created an access list called ACL in, and so all the devices on our inside network will be permitted to go out of our network. Then we go ahead and we apply that access list, and once again these two names are identical. And then what interface are we applying it to? And so once again, this ACL allows all hosts on the inside network to go through the ASA. Another example here is we have an ACL that prevents hosts on the 192.168.1.0/24 from accessing the 209.165.201/27 network. We also throw in that internal hosts are permitted to access all other addresses. Go ahead and we start setting up our access control entries. So we have access list here, call it access control or ACL in. It's extended. We're going to deny because that was our requirement. IP, and then we're putting in a network address, a subnet address here of 192.168.1.0 with a /24, and traffic destined to the 209.165.201 with a /27. So we're going to deny any traffic starting on the 192 network going to the 209 network. Then we're also going to allow any other internal devices to all other addresses. And that's what the second ACE does. Once we've created our access list, then we go ahead and we apply it using the access group command. We specify our ID, once again, is ACL-in, what direction we're going. So any inbound traffic on interface inside. Let's talk about an example in which access from two trusted remote hosts, and that would be PC1 and PC2 here, should be allowed to the two internal web and email servers. Over here on the inside of your network, we have one internal web server, and then we have a second internal web and email server. All other traffic attempting to pass through the ASA from the outside to the inside, that should be dropped and logged. The ACL will require 2 access control entries for each PC to accomplish this task. The implicit deny any drops any and logs any packets that do not match email or web services. As you work on your ACLs, you should always remember to remark your commands. As you work on those ACLs, they're fresh in your mind. When you have to come back in a week, in a month, in 6 months, in a year to modify something, a lot of times it's hard to remember what you did. So you should always thoroughly remark that. Now, once you have all your access control lists set up, we have our 2 show commands again. One command here is show, run, and then access list. Second command here is show, access, -list. These 2 show commands here will give you your information about your access control list so you can verify that you have them set up correctly. Object grouping is a way to group similar items together to reduce the number of access control entries. Object grouping can cluster network objects into one group and outside hosts into another. The security appliance can also combine both TCP services into a service object group. Using the example we talked about a couple minutes ago, let's use that example again and talk about object groups and how they can work together. Let's configure a couple object groups and then show you how we can use those in access control lists. First thing we're going to do here is create an object group. Object group network, and we'll call it nethost. And the description here is the OG matches PCA and PCB. So we're identifying 2 PCs. And once again, that's from our network right here, PC1. Those are our trusted PCs. So we create a network object inside of our group for the host of PCA, and then a network object host for PCB. That's all we need in this object group. So go ahead and type exit. Let's create a second group here. So object group network, and we'll call it servers. That will identify our inside servers. So we have 1, we have 2. So we create, or we add in a description, OG matches web and email services. And because these are 2 IP addresses, we just identify those 2 hosts. So network object host for web server 1, or email and web server, and then we create another network object host for email web server 2. That's all we're putting in there. So far we've created an object group for the trusted PCs on the outside network. We created an object group for the servers on the inside network. And then let's create a third object group here, and we'll call it HTTP or SMTP TCP. And what this is according to our description, is OG matches SMTP and web traffic. So we're just allowing simple mail transfer protocol traffic and web traffic with this. And to specify that, we set a port object equal to SNM or SMTP and a port object equal to web traffic, www. That gives us our third object group. Now let's take those object groups we just created and put them into an access control list. Down here we can see we are looking at access list, ACL in, so that's the name of our ACL. We created a mark, and this only permits PCA, PCB to the internal servers. So we're going to remind ourselves what this access list is for. Then we go ahead and actually create or put in our access control entry. So access list, ACL in, it's an extended list. We're going to permit TCP traffic, and instead of using a host or an IP address, we're going to specify object group, and then we're going to say net hosts. And once again, net host is the first object group we created here. So our trusted external PCs. Then they're connecting into the object of servers, which is the second object group we created here. And what are we allowing here? Well, that's another object group. That would be our HTTP SMTP object group that we created third. By creating these object groups, we don't have to specify all of these access control entries, and it cleans up our access control list a little bit by using. It was my pleasure to provide you with this wonderful episode on ASA access control list. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on network security for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.